Hey, this video is for my calculus class, and this is Limit Lab 2, where we're doing one-sided and infinite limits. So I'm going to do as much of this as I can without this being too long, but you can go back and look at and see how we're doing. So this is the first one. It says, use the diagram of f below to answering the following questions. They want to know the limit as x approaches infinity. So in positive infinity, as you know, is here to the right. Negative infinity is here. For y, it's positive infinity, and down here it's negative infinity. So just kind of that doesn't look good. That just kind of gives you an idea of, kind of sets you up here. So as we go to infinity to the right of this function, it looks like it's approaching this horizontal asymptote, or 1. The limit as we go to negative infinity, that's over here of this function, and it also, this one looks like it's approaching 0. Okay. The limit as we approach 2 from the left. So if I'm coming from the left, I'm going to come this way, and I'm going to approach 2 from the left. You see how our function goes down all the way down to negative infinity. And you can shut this off at any time and then come back and say, did I do it right? Okay. The next thing it says, the limit as I approach 2 from the right. So I'm coming this way to the right, and it looks like I'm going to positive infinity. You don't have to write the positive. And then the general limit as I approach 2 from the left and the right, I'm going to say it does not exist because the left and the right hand limits don't equal here. Okay? They don't equal. Okay? For f, the limit as x approaches negative 1, and when I approach negative 1, it's here, so I'm going to come from the left and from the right. It looks like it approaches 2 on both sides. But if I were to actually find f of negative 1, that's an open circle. That point does not exist. So that's just kind of some practice with infinities. Now we're going to evaluate a bunch of things. And the one thing I want you to know with infinity, you're talking about your tails of your graph. If you're talking about your right and left hand tails, you're usually talking about your horizontal asymptote. So if I'm looking at my left hand tail or my right hand tail, I'm usually talking about what am I approaching to the left and right. So this is where you have your plus and minus infinities here. If you have a number over 0 and you're trying to figure out what this is usually your vertical asymptote, and your number is going to be, your answer is going to be plus or minus infinity. So here you're going to approach plus or minus infinity, and you have to come up with an answer. For the vertical asymptote, you're going to get a number over 0, and that your graph will approach positive or negative infinity. Let's practice some. All right. So I graph this first one. X approaches 5 from the left. So if you plug 5 in there, so I'm going to use a different color here. I have a 10 and I have a 0. Okay, so a number over 0. If I get a number over 0, I know my answer is going to be positive or negative infinity, because that means there's going to be a vertical asymptote. The only way to really look and know is to actually look at your graph. So I did graph this one. So this is our very first one. As I go, I'm approaching 5 from the left. It looks like it's going down to negative infinity. If I was approaching 5 from the right, it'd go to positive infinity. Do you see where x is equal to 5 is my vertical asymptote? Okay, so you kind of have to graph these to really see what's going on. I mean, you can test it by putting the number in, even though it says left or right, but you want to make sure you know it's going to be positive or negative infinity. And we just looked, and it was negative infinity. We just looked at when it approached 5 from the right, it was positive infinity. Okay. Now the general limit, when I approach this function, see how this is always the same function from both sides, I'm going to say it does not exist because the right and the left hand limits do not match. Okay. It's as simple as that. There's really no algebra to do. You still want to substitute and get it and figure out you have a number over 0. So here I put a 3 in, I get a number. Okay. And if I put a 3 in here, over 0. So I know my answer is going to be plus or minus infinity. How do I know? Look at the graph. So now I graph that one. That's our next one. So I'm going to come here. And as I approach 3 from the left, So I'm approaching 3 from the left. I'm coming here. It looks like it's going to positive infinity. Then I want to approach 3 from the right. It looks like it's negative infinity. And then if I ask for the general limit, it's not going to exist because the left and right hand limits don't match. So this is, again, the same kind of practice. So from the left, I said it approached infinity. From the right of the same function, I said negative infinity. Therefore, the general limit does not exist. And don't forget, you guys learned these are rational functions, that we always put our denominator equal to 0 to find the vertical asymptote. So you know these are vertical asymptotes. These are all rational functions. And you're just going to have to graph these to kind of see, is it your answer positive or negative infinity? All right, the next one is a radical, and it's a square root. And this one, remember, square roots can only be positive they can be 0 or anything positive. So I graphed this one, and here's x, the radical x minus 4. So it looks like from 4 on, this graph exists. It doesn't exist over here. So the first one they ask us is if I approach, now this is not a vertical asymptote, it's not a rational function, it's just a regular radical. If I approach 4 from the left, I can say, oh, my graph doesn't exist because it doesn't. Okay? If I approach it from the right, it looks like it approaches 0. Okay? And how I do this is I plug the 4 in there. So I got a 0 when I plug this in. I got a 0 when I put that in. But as you'll notice when I come from the left, therefore, my general limit does not exist because my right and left hand limits don't match. So even if it's not a rational function, you need to graph it and see if, especially if it says left and right hand limits. Okay? Let's continue on. Now I have a couple piecewise. Now you'll know why I did piecewise function. They want you to find limits with these piecewise functions, okay? So I graph this right here. So that's our next one. So I see that it's 3x plus 4, and then at 2 is our breaking point, and then it's 4x minus 5. So it's pretty steep right here, and that's what our graph looks like, okay? So we want to know what the limit is. Well, basically, you're going to plug it in and see what you get, and then see if they are going to match. So the first one says you want to find the limit when you approach 2 from the left and 2 from the right. Well, with a piecewise function, that's pretty easy because when I come from the left, all right, that's going to be this bottom piece, all right? So I'm going to do 4 times 2 minus 5, or I'm going to get a 3. So the limit when I approach 2 from the left is 3 because it's going to approach a y value of 3, even though 2 doesn't belong in this piece, but this is the left. This is all the numbers smaller than 2. When I approach 2 from the right, that's going to be the top piece because these are all the points greater than 2. I'm going to do 3 times 2 plus 4. So that comes out to be 10. So this is approaching 10 from the right. Now you can check the graph and find the points that you want. This point right here doesn't even exist, so it's not even going to show on your table, but that's what you're approaching. Now, here's the general limit, the limit of this function when I approach 2 from the left and the right. I'm going to say, you guessed it, does not exist because the left and right hand limits here do not match. Okay? Now, when I want to find f of 2, I have to use the top piece. So it's going to be 3 times 2 plus 4, which we already did for b, is 10. So the point 210 is actually on the graph, and that is the function. So this is why I had you learn piecewise functions before, because you can do limits, find points, and all sorts of things, okay? Let's look at this next one, another piecewise function. I graphed it. And I've got it coming here. It looks like a line, even though it's a little curved, and then it's x squared plus, oh, no, this is x squared plus 2 is the parabola here, and then x plus 4, it's when it's greater than negative 1. So this is when it's less than negative 1. All right, let's go and do this. So I need to find what they want to do here, and they want to do the limit when you come from 1, negative 1. So obviously it's right here, okay? So I'm going to be coming from the left, coming from the right, and again, you can look at your table. So the limit when I come from the left of this is the left is going to be all these points smaller than here. So I'm actually going to put a 1 in here. So I've got 1 squared plus 2. So I'm going to get a 3. So that equals 3. Is that on the graph? No. It asks me when I am approaching it from the left. Notice negative 1's not even on this graph at all. Do you see that? It's negative 1's not on this graph at all. Now when I come from the right, it's everything greater than negative 1. I'm going to use the top piece. So I'm going to put negative 1 plus 4. I get 3 as well. And look, they match, which they did come together. So I was kind of thinking that would happen. Now the general limit when I came from negative 1, okay, the left and right hand limits match, so it's going to be 3. And if you plugged it in, all right, you're going to get the same one, either piece that you use, okay? All right, I keep doing this on the graph, sorry about that. Now the next one is f of negative 1. Does f of negative 1 exist? And I showed you here there's no line, so f of negative 1 does not exist. We can do the limits, but the point negative 1 is not even on the graph. There's a hole there, even though your graphing calculator doesn't really show it. Okay, now this next piece is number 6. Now the only thing with number 6, I'm going to move it way down here, is some of these didn't show up. So I'm going to, in class, do this with you, but I would stop the video and copy all of these down so that as we go through this, that you can put your answers in there. So I'm going to keep going, but stop it because for some reason, these all got cut off. Okay, so I'm going to do, as x approaches negative 2 of this function, right? So when I go left and right, it looks like my limit is 2, okay? When I approach 2 from the left and the right, okay, I said, okay, I'm approaching 2, so I'm coming from the left. It looks like it's 4. And when I come from the right, oh no, that's a positive 2. So this was negative 2, sorry. So this is a positive 2. So when I approach 2 from the right, it looks like the limit's 4. When I do 2 from the left, it looks like the limit's negative 3. So this does not exist. I think the answer key is wrong on this one because I think I looked at it as negative 2. All right. Now, as x approaches negative 5 from the left and right, it looks like they're both approaching 7. Okay. Now we're going to do D, E, and F. So D says f of negative 5. So f of negative 5 is actually the point negative 5, 3. So because that point is actually on my graph. Okay. The limit as I approach my function x approaches 4, it looks like from the left and right, it's negative 2. Even though that point doesn't exist, f of 4 does not exist because there's a hole in the graph. All right. For G, the limit when I approach 1 from the left, so I'm coming 1 from the left, I get a negative 3. When I approach 1 from the right, I get a 4. Notice up here, actually, B, this is wrong. It's 2. I was looking at 1. When I approach 2 from the left and the right, the answer is 2. So I apologize about that. If you caught that, you're like, Mrs. Pond, you don't know what you're talking about. I was looking at 1. Sorry about that. And then as I approach 1 from the left and 1 from the right, that means my general limit does not exist because the right and left hand limits do not match. Okay? And the last one they want me to do is f of 1. So when I do f of 1, the actual point is the point 1, 6. So f of 1 is 6. It's the point 1, 6. So go ahead and do that. I'm sorry about B. The answer is 2. I was looking at 1. I don't know why. So make sure that you fix that. Okay? Let's go back. Now we're going to start at 7. Now it says find the limits of the following. So I'm going to help you with this as we do this. You know what? I might make this a new video so that it's not quite so long. So I'm going to stop this video and chunk it up a little bit so it's not quite so long. So wait for the next video, guys.